Almost everything we do online, sending messages, using a credit card, and even logging into a website depends mostly on one kind of digital lock, called elliptic-curve cryptography. But the only reason we trust it is because nobody has been able to break it efficiently so far. So my research asks a dangerous but important question. What if we tried to break it with an AI-based method? At the heart of the elliptic-curve cryptography is a math problem. An elliptic curve is a curve of the form y squared equals to x cubed plus ax plus b, often shaped like these. You're given 2 points on an elliptic curve in a finite field called P and Q, and you know that Q equals to K times P, but you don't know K. And that number K is the secret key. So far, the fastest known way to recover key is to use an algorithm called Pollard's Row. It basically wanders through the math space of an elliptic curve in a pseudo-random way, hoping to stumble into the answer. It works, but it's blind and somewhat random. And that made me wonder, what if we, instead of wandering randomly, we let an AI learn how to search? So I built a reinforcement learning system, the same kind of AI used in self-driving cars and game-playing programs, and trained it to attack this cryptographic problem. My idea was to let the AI explore through trial and error and slowly discover patterns on the elliptic curves or finite fields that humans might miss. And something remarkable happened. When I trained the AI on a specific elliptic curve, it actually learned how to outperform Pollard's Row, the best known attack, by finding smarter paths through the math. Right now, however, this only works in controlled settings under a fixed finite field with a fixed curve and fixed keys P and Q. But that's a good starting point. My research matters because modern cryptography isn't guaranteed safe. It's only proven hard to break so far. By attacking it with AI, we aren't weakening security. We're measuring how strong it really is and how it motivate or inspire the design of the next generation of cryptography before attackers do.